What we're going to do is we're going to look at multiplying rationals again. This time we're going to not only simplify, we're also going to state the excluded values. Now, simplifying, remember the key is factoring. So looking at our first fraction, our numerator stays the same. There's nothing we can do to factor it. Our denominator has an x in common. So we factor out an x, and then that gives us an x minus 3. For our second fraction, what we notice is that they have an x in common, but after we factor out the x, we notice that we can still factor it some more. That's a special factoring pattern, a difference of squares. So that would be x, x minus 3, and x plus 3. Our denominator is a trinomial, so we're going to use the x method. Two numbers that multiply together give us negative 12, add up to negative 1. That would be negative 4 and 3. So that would be x minus 4 and x plus 3. Now, when we're looking at this, we did the hard part. Now the easy part, we get to cancel. So we see that they have an x plus 3 in common. We see that they have an x minus 3 in common. We see that they have x's in common. So what's left over is an x plus 3 and an x minus 4. That's how we simplify it. Now, stating the excluded values, what we do is we go to our original problem and we find all of the zeros. Not our final answer, but our original problem. So our excluded values, x cannot equal. The first one, whenever it's a monomial, it's always 0. If we plug in a 3 there, 3 minus 3 is also 0. If we plug in a 4, 4 minus 4 is also 0. And if we plug in a negative 3 plus 3 is also 0. So those are all our excluded values. If we use any of those values, the denominator is 0. And remember that we cannot divide something by 0. So that's why we want to make sure we do not have those numbers. Now, looking at the next one. We see we have monomials. So there's nothing we can do to simplify it. We just keep it as x to the 5th and then 6x squared. For the second one, we see that they have a 3x in common, and that would be an x minus 5. Here we have difference of squares. That's our special factoring pattern, x minus 5 and x plus 5. Now for the fun part, what we get to do is cancel. We see that we have an x minus 5 in common. The 3 and the 6 can cancel. Remember, when we're looking at exponents, whenever we divide, we subtract the exponent. So 5 divided by 2, 5 minus 2 would be x to the 3rd. So this becomes a 3 because whenever we divide, we subtract the exponents. So our final answer is x to the 3rd times x, which is x to the 4th. And we have an x plus 5. That right there is us simplifying it. Now we're going to look at our excluded values. Once again, we're looking at our original problem. And what we're doing is we're trying to figure out what gives us a 0. Here, whenever we have monomials, whenever you plug in a 0, it's always a 0. Here we have a 5. And here we have a negative 5. So we could put plus or minus 5, or if you like, 5 and negative 5. Okay, looking at the next one, what we're going to do is we're going to factor it. We see that our numerator has a 3 in common, and that gives us x squared minus x minus 6. Since it's a trinomial, two numbers that multiply together give us negative 6. Add up to negative 1 would be negative 3 and 2. So we have a 3 on the outside, x minus 3 and x plus 2. Our denominator, two numbers that multiply together give us negative 3, add up to 2. That would be 3 and negative 1. So that would be x plus 3 and x minus 1. For our second fraction, we see the 3 in the front. So we remember that 3 times 1 is 3, adds up to 4. That would be 3 and 1. But we divide it by 3 because that's our leading coefficient. That would give us x plus 1 and 3x plus 1. For our denominator, 3 times -2 is -6. And -5. Two numbers that multiply together give us -6. Add up to -5 would be -6 and 1. We divide each of these by 3 because that's our leading coefficient. That would be x minus 2 and 3x plus 1. Now, for the fun part, we get to cancel. When we're looking at this, we see that the 3x plus 1s could cancel. What else can cancel? That would be it. So what we have is a 3. We have an x minus 3. We have an x plus 2. We have an x plus 1 over. We have an x plus 3. We have an x minus 1. And we have an x minus 2. Sometimes when we look at this, it doesn't seem like we simplified it that much, but we did. Now, excluded values. What would be our excluded values? Our excluded values is what gives us a 0 in the denominator. So when we're looking at this, x cannot equal. We have -3. We have +1. We have +2. And we have -1/3. Pause the video for a second and try those next ones and see how you do. Okay, looking at these next ones. We have a x cubed. The denominator, they have an x in common, so that would be x minus 5. Our second, what we're going to do is we're going to factor it since it's a trinomial. Two numbers that multiply together give us -36, add up to -5, and that would be -9 and 4. So we have x minus 9 and x plus 4. Now remember, if we don't have a fraction, we put it underneath 1. So when we're looking at this, we see that the x and the x cubed can cancel. And so that gives us x squared and then x minus 9 and x plus 4. Our denominator would be x minus 5. Now, when we're stating our excluded values, we have x cannot equal. Monomial is always 0. That would be a 5. So it would be 0 and 5. Okay, looking at the next one. We have an x in common, and that gives us an x plus 7. And then what we have is our special factoring pattern, x minus 7 and x plus 7. So we're going to do the fun part, which is canceling. 4 and 2 cancel, 1 and 2. We know that the x plus 7 cancels. X squared and x to the 6, whenever we divide, we subtract the exponents. So 6 minus 2 gives us 4. So our answer is 2, or I should say x times 2x to the 4th, which would be 2x to the 5th, over x minus 7. So that's our simplified answer. When we're stating our excluded values, x cannot equal. We're looking at our denominator. Monomial is 0. And then what we have is 7 and -7. Okay, last one. We see that they have a 5 in common, but when we factor out a 5, it becomes x squared minus 4, which we can factor some more. So that would be x minus 2, x plus 2. For our denominator, 2 times 2 is 4. So two numbers that multiply together give you 4, add up to 5, which would be 4 and 1. We divide each of those by 2. So x plus 2 and 2x plus 1. Then for the second one, two numbers that multiply together give us 30 and add up to 13. That would be 3 and 10. So that would be x plus 3 and x plus 10. Two numbers that multiply together give us negative 20 and add up to 8. That would be 10 and negative 2. So we have x plus 10 and x minus 2. So looking at this, we're going to see what we can cancel. And we have the x plus 2's. We have the x plus 10's. We have the x minus 2's. And so we end up with 5 and then x plus 3. And in our denominator, 2x plus 1. That right there is our simplified version. Now we're going to state our excluded values. So when we're looking at our excluded values, x cannot equal. This would be negative 2. Here we have negative 1/2. Here we have negative 10. And our last one is 2. Now, most of them are self-explanatory except for the fractions. That's always a difficult one. So if we were to isolate that and we were to say 2x plus 1 equals 0, we would subtract the 1 and then divide by 2. And that's how we're getting x equals negative 1/2.